Good evening. Today we are going to see the continuous beam analysis of continuous beam, and that is by stiffness method. So already one video I shared, and in which we are with proper cantilever. So now in this we will go with continuous beam. So we have question analyze beam ABC as shown in figure. As shown in figure by stiffness method. We have beam ABC. So we have this as 6 meters. Then concentrated load at center. So 2 meters, 2 meters. Then load we have 60 kilonewton. And this is UDL 40 kilonewton per meter. So this we will keep, we have to plot all the diagrams. For that one, we will be this portion. So now we will start with now see, listen very carefully. Tomorrow we have to solve problem on this. So we have step 1, kinematic indeterminacy. Step 1, kinematic indeterminacy. So we have decay. Now we have this as fixed support, no displacement. Here we have theta b, so we will give name to theta b as 1. This is theta c, we will give name to it as 2. So we have decay is equal to 2 as shown in figure. These steps we have for all the problems. It may be frames or beams. Then we have step 2. We have step 2, fixed rate moments. Fixed rate moments. So we have to make all supports are considered as fixed. So that structure become kinematically determinate. Structure becomes kinematically determinate. So we have now kinematically determinate structure. We have to make all support as fixed. This diagram plays very important role. If you will draw this diagram properly in the examination, then no one will go to your steps and your calculations. So be very careful. This diagram plays very important role in stiffness method. So 6 meter. This is given view. This is kinematically determinate structure. So A, B, C. Now we will find fixed end moment. So we have MF, AB. minus WL square by 12 minus WL square by 12. So minus 120 kilonewton meter. Then MF B8 WL square by 12 120 MF BC minus WL by 8 minus 30 and MF CB WL by 8 and that is 16 to 4 by 8 30 kilonewton meter. Then we have to go for stiffness method. So we have step 3 stiffness method. We will go for stiffness method. We have to apply unit displacement at unknown displacement one by one. So now we will apply unit displacement at B. So unit displacement at B and we will go clockwise. So unit clockwise displacement we will apply over here. So we have B over here. Clockwise, so we have clockwise over here. So at B only, so at A we have 0. So we have this will be theta B equal to 1. So you can see we have 0 A value. So how much moment we require, that already we have seen. We require 4 EI, we have 2I and L we have 6. So this is 4 EI upon L. And then we will get it 4 by 3 EI. This is for BA. Now we have for BC again clockwise we have to go below and then we have likewise C should be 0. You can see C 0. So theta C equal to 1. And then we have this value 4 EI by 4. And then we have that is equal to EI. And here we have 2 EI by 4. And that is 0.5 EI. Now we have unknown displacement. This is number 1 and this is number 2. Now we have to write down elements of stiffness matrix. So we will say we have we have to first write always displacement number. So we have this as 1. So I have 1. Here we have 2. So I will write 2 as 2. Now where we have applied unit displacement, theta B is 1. What is number of this displacement? We have number of displacement is 1. So second digit we have both 1 1. So now then what will be S11? So we have this value which will be applied at B. We have this value which is applied at B. So I will get S11 equal to 4 EI upon 3 plus EI, and that is 7 EI by 3. And S2 and we have only one value 0.5 EI. What is S11? So try to understand. S11 means force required at first unknown displacement due to unit displacement applied at first unknown displacement. S21 force required at second unknown displacement due to unit displacement applied at first unknown displacement. So this is for unit displacement applied at 1. Now we will go unit displacement we will apply at 2. That is theta C equal to 1. Again, we have to go clockwise. We have to show moment that is clockwise. So theta c equal to 1. We have to go clockwise. We have just keep pen over here and just move it clockwise. And then we have this will be 4 ei upon. Now you can see theta b 0 and we have theta c equal to 1. And we require over here 4 ei by 4 and that is ei, and here we have half 2 ei by 4 that is 0.4. So now again we have these values that we have to give element numbers. So we have this will be at S1, this is S2. Now where we have applied unit displacement at C and my number of this is 2. So we have this is number 2. So apply second digit S2, S2, 1 to S2, 2. So we have S1, 2 that is equal to 0.5 EI. We have this value. And S2, 2 we have EI and that we have this value. So what will be our stiffness matrix then? Then we have EI if we will take common, then we have 7 by 3, 0.5. This is symmetric matrix, 0.5 and then we have 1. So we should have S12 should be equal to S21. So now we have stiffness matrix. Now we will go, we have step 3 already we have completed. Now we will go with step 4. So we have step 4. Formulation of simultaneous equation. Step 4. Formation of simultaneous equation. Formation of simultaneous equation. Now we have general equation is FD is equal to FDL1 plus or FDL plus S into D. FD we have force applied externally, force applied externally at unknown displacement. Externally at unknown displacement. Then we have FDL, force at unknown displacement due to external loads. Force at unknown displacement due to external loads. As we have stiffness matrix, and D we have unknown displacements. So now we have 2. So we have FD1 is equal to FDL1 plus S11 D1 plus S12 D2. Now we have to find out and second equation we have FD2 is equal to FDL2 plus S21 D1 plus S22 D2. Now as no external loads directly at unknown displacement, so we have FD1 equal to FD2 equal to 0. Now FDL1 we have fixed end moments. Now at B we have MBA plus MBC. MBA we have 120, MBC we have 30. So FDL1 is 90 kilonewton meter. Then we have FDL2. Now here we have only one member which is MCB and we have that as 30 kilonewton meter. Now we will substitute all these values in this equation. Now we know we have this value that is S11. So S11, S12, S21, S22. So now we will substitute all these values. So we will get from this 0 equal to FDL1 is 90. We are substituting in this now. Plus 7 by 3 EI theta B. So this is 3 plus 0.5 EI theta C. And from this we will get first equation 7 EI theta B by 3 plus 0.5 EI theta C equal to minus 90. This is equation 1. Then we have second 0 equal to 30 plus 0.5 EI theta B plus EI theta C. And then we will get this equation as 0.5 EI theta B plus EI theta C equal to minus 30, equation 2. And then we have, this is step actually 4. And then we have step 5. Solution of unknown displacement. So solution of unknown displacement. And then solving these two equations, solving 1 and 2, we have EI theta B equal to minus 36 and EI theta C equal to minus 12. And then we have last step, step 6, final moments. Final moments. So we have to use slope deflection equations. And then we have this as MAB equal to MFAB plus 4 EI upon L theta A plus 2 EI upon L theta B. Now theta A has fixed at 0. So we have minus 120 plus. Now we can see this. We have EI over here. So we have actually in example, this is 2 EI. And this is EI actually that I have not mentioned. I have considered over here, but I did not mention in the example. So AB we have 2 EI and BC we have EI. And then now we will go with minus 120 plus. Now we have 2 by 6. EI we have 2 and theta B we have minus 36. And then it comes 6, 6 minus 6 minus 24. And then we will get this value that is equal to minus 144 kilonewton meter. Then we have next MBA. We have MFBA. So we will go to the next. So we have MBA equal to MFBA plus 2 EI upon L theta A plus 4 EI upon L theta B. Then we will have theta A 0. So 120 plus 4 upon 6 into 2 EI minus 36. And we will get this value as 72 kilonewton meter. Then we have MBC, MFBC plus 4 EI upon L theta B plus 2 EI upon L theta C. We have this MFBC minus 30 plus 4 by 4 minus 36 plus 2 by 4 minus 12. And then we will get it as minus 72 kilonewton meter. So you can see MVA that is equal to MVC. And then we have last MCB, MFCB plus 2 EI upon L theta B plus 4 EI upon L theta C. And then we will substitute the values 30 plus 2 by 4 into minus 36 plus 4 by 4 into minus 12, and we will get it as 0. So we have these values MAB, we have minus 144 kilonewton meter. MBA, we have 72 kilonewton meter. MBC, we have minus 72 kilonewton meter. And MCB 0, it should be 0 because it is end support, simple support. So we will stop here only. So next part we will see in the next video. So thank you.